Hello again. In this second session on Mikebaba-CATIA, we are diving into the more section of the draft tool. We will cover industrial concepts like parting, elements, and material options, which are vital for professional plastic part design. Let's dive in.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With Katia, I cut through strife. In my mind, the future's clear. No more doubts, no more fear. Crafting visions in 3D. Katia's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. Katia helps me innovate. Every line precise and true. Colors bright and brand new.
Hello everyone. So far we have reviewed the first part of the draft tool together. In the previous part we discussed options such as draft angle, face to draft, neutral element, and the pulling direction. Now I click on the More button so the second part of the settings window opens. The second section itself has three subsections. The first section is called Parting Element. If you remember, we had this same option in the fillet tool. Here we have an option with a similar name, but here we have a fundamental difference. This option here is based on mold making logic. For the part to come out of the mold, we apply a slant to our shape from two sides. Here we consider a surface from which the part is drafted in two directions. This surface is not necessarily parallel to the neutral surface, although in the most cases it is parallel to the neutral surface. Even the parting surface can be aligned with the neutral surface. In the design of complex automotive parts or household appliance bodies, sometimes the parting line must go around the part in a broken or curved way due to the specific form of the body. Otherwise, I click in the selection box. I select a plane. By doing this, I define the parting boundary. If the selection box in this section is empty, drafting is performed on one side. Note that the parting element, without checking draft both sides, only acts as a stopping point for the draft. For example, consider this shape which has an bean-shaped cross-section. I padded this section and gave it a height of 60 millimeters. Then I created a plane at a distance of 30 millimeters from the XY plane. Now I activate the draft command. I select the side surface as the surface to be slanted. I select the top surface of the part in the neutral element section as the neutral surface. I select the z-axis as the pulling direction. Now I click in the selection box of the parting elements section to highlight it in blue. Now I click on the plane I created. I click OK. You see that from the plane's position to the neutral surface, the shape is slanted and connected to the bottom part with an edge. One side of my volume is without a slant. By changing the orange arrow's direction, the situation is reversed. Now I delete the created draft. I activate the command again. I keep the previous settings up to the parting elements section as before. Here I activate the parting equal neutral option. In the neutral elements section, I click on the existing plane. I click OK. You see that the result has changed. Now in the same state, I also activate the draft both sides option. You see that the shape became slanted from both sides. There is another part in this window called limiting element. If we want to slant only a part of a surface, we use this option. For this, consider the same cube. I draw two planes parallel to the ZY plane. I activate the draft command. I set the angle to 20 degrees. I want to slant one side surface of the cube. I select it. I select the top surface of the cube as the neutral surface. Now in the limiting elements section, I select one of the drawn planes. I click on Preview. A semi-transparent blue plane appears covering the whole surface. But a pink line is also displayed. This line extends from one of the edges to the selected plane. An orange arrow is also seen on the selected plane. If I click on this arrow, its direction and the location of the pink line change. Now I click OK. It is seen that only part of the selected surface became slanted. If I select two planes, I can slant the space between the planes or outside of them. First, note that an arrow is seen on each of the planes. Second, note that the arrow's direction must be either towards each other or opposite to each other. In the last section, we have an option called Material Options. To simplify, consider a hollow shape such as a pipe. When a shape is made, it has an internal surface and an external surface. During design, it must be specified whether internal surface accuracy or external surface accuracy is important. For example, the inner dimension of the pipe must be precision. With this option, we specify which direction material volume should be added or removed during the draft tool application. This option directly relates to controlling thickness, tolerance, and mold quality. This option has 3 modes. The first mode is Add Material. In this mode, the draft is applied so that material is added to the part. CATIA does not allow any part of the original part to become smaller. This option is used when we want to guarantee minimum thickness. The second mode is Remove Material. Here the draft is applied by removing material. Here the surfaces rotate inwards and the part volume decreases. CATIA does not allow the part to become larger than its current dimensions. The third mode is Add and Remove. Here CATIA tries to minimize the volume change. Therefore, material is added on one side of the rotation axis and removed on the other side to create the angle. Tip: material options always works in combination with a neutral face. Now it's time for the draft form option. There is a box in front of this option. I click on the V symbol in this box. A drop-down menu opens. You see 2 different modes. The cone mode, which is the default. This mode is preferred for plastic and cast parts. The other mode is called square. In this mode, the corners remain sharp. Suppose we have a cube. The corners of this cube have a large chamfer. I activate the draft tool. I set the slant angle high, for example 25 degrees. I select the side surface of the cube as the surface to be slanted. I consider the top surfaces of the cube, including the chamfers, as the neutral surface. First, pay attention to the arrow shown. This arrow is currently in a specific direction. If I click on Preview in this state, I encounter an error. Now I click in the box in front of the Pulling Direction option. I click on the top surface of the cube. Now the arrow direction is corrected. In the Draft Form section, the mode is on cone. In this state, I click OK. Pay attention to the form of the two drafted side surfaces. I double-click on the draft icon in the specification tree. Its settings window opens. Now I set the draft form mode to a square. I click OK. You see the change in the shape of the side surfaces. Now consider the same cube but with large fillets on its corners. I activate the draft tool. I set the settings the same as before. I set the draft form mode to a square. I click OK. You see that the side surfaces also participated in the slant. I double-click on the draft in the specification tree. With the same settings, this time I set the draft form mode to cone. I click Preview. I encounter an error. This error says that the neutral element is too steep. Now I go back one step. I make the draft angle very small. I set it to 3 degrees. Draft form should be on cone. I click Preview. I receive the same error again. So, how is the problem solved? Here, if there is insistence on using cone mode, first the cube without fillets must be drafted. After that, the edge fillets should be applied. Okay, the lesson is finished here. Please see the lesson carefully. Practice with me in second time. Good luck Goodbye until next lesson.
Go with me. Let's build a